Hello, my homebound students. Today we're going to move on to a new topic. We're going to look at energy. It's very important to all of us, from every phone you plug in, computer you use, every time you watch Netflix, drive your car, heat your home, all these things use energy. So we need to look at what makes energy important and what are the different types of energy that we use and what are advantages and disadvantages of each. So here's where our electricity energy comes from. And you can see that most of it comes from fossil fuels. So 34% is natural gas, 30% is coal, 20% is nuclear. Our next section here is hydroelectric, and then we move into wind and all of these other ones. So most of the stuff we use is what we call non-renewable resources. If at any point I go too fast, it's a video, pause it. That way you can write down the important information. Okay, so why do we use fossil fuels? Because they are incredible in what they can do. In a small package, a gallon of gas, something like that, okay? We can travel and take a 3,000-pound vehicle, a gallon of gas, and go 20 to 30 miles, depending on the type of vehicle that you have. To do the same thing as a person, on a bicycle, on foot, takes a tremendous outlay of energy. That's why most people don't travel that way, because we have this super easy, cheap way to do it. And right now, gasoline is like $2.20 a gallon. So for $2.20, you can travel 30 miles and carry a bunch of stuff and other people and all kinds of things. To give you an idea how it works out, if you could run up 3 flights of stairs in 20 seconds, that would use about 1 horsepower of energy. And a normal human can't sustain that. So normally humans work at about 1/20th of a horsepower. So in other words, to run a 150-watt light bulb, you would need 5 people to work continuously to produce the energy that is in that 150-watt light bulb. On average, you and I have 150 energy slaves, as it is, working for us every day. Now, when we talk about energy slaves, we're talking about the energy that is being produced by these fossil fuel sources. A 100 horsepower vehicle, which there aren't very many of those, usually they're more than that, uses 2,000 energy slaves. So this is essentially an incredible energy source. We haven't found anything that works like this in a small, compact, portable unit yet. So this is incredible, and that's why we use it. And we have for 150 years or so. And what it's allowed us to do is develop the lifestyle that we're used to today, all the electronic devices that are, and heating sources and transportation, whether it's ships or trucks or planes. Our farming style is totally based on this fossil fuel economy. So to take all of that away would be really difficult at this point. And so that's why we use that, because for us to do it as humans, it takes a tremendous amount of work to do what a gallon or 2 or 3 of fossil fuel can do. So that's why we've used fossil fuels for so long. Okay, so the first fossil fuel we're going to talk about is coal. Coal has some distinct advantages. The reserves of coal are huge. In the United States alone, there's at least 200 years of proven reserves of coal, and it might even be more than that. And most of the coal, I think 90% of the coal, is in the United States, Russia, and one other country. So we've got lots and lots of coal, and it's actually in the United States, which is an advantage to us. It's inexpensive to mine. The ways that we do it are fairly simple, whether it's strip mining away the surface, mountaintop removal mining, or coal mining, underground coal mining. It's all relatively easy to do. We can put it in rail cars, we can put it in trucks, we can put it in ships, and we can move it around pretty easily and cheaply that way. And then you use it by burning it, and so that's relatively easy. And a lot of these coal-fired power plants that you see pictured here are actually located very, very close to the coal resources themselves, so the transport costs are even lower. Some of the disadvantages. It's not very efficient, so if we burn coal, we're only getting less than 40% or roughly 40% of the energy possible from it when we burn it. So we're losing 60% usually to residual heat that's given off and not trapped in producing energy. The mining methods that we use, whether it's mountaintop removal mining, which is exactly what it sounds like, we come in and blow up an entire mountaintop and push it into the valley next to it, and then strip the coal away from that area. Or we do strip mining, which you take off the top layer and we just dig out all the coal. And underground mining is certainly dangerous. One of the most famous illnesses in coal miners is the black lung. Sorry about that. And they're environmentally destructive. So all of these things drastically change the surface features. There's a lot of talk about clean coal, gasifying coal, sequestering the carbon emissions from this, putting them into the ground and trapping them until they become rocks. And all of that is very theoretical. It hasn't really been tested on a wide scale, so it's not particularly something that we can depend on yet. It's just a possible idea in the future. And we'll look at some of those. And of course, carbon dioxide is, coal is the dirtiest of the fossil fuels. Its release of carbon dioxide and other pollutants, it actually can release more radioactivity than a nuclear power plant can. And then we have the coal slurry, the leftover ash that's taken out of this. They put in these ponds, and that's very, very toxic stuff. And some of the ponds have failed and flooded areas and contaminated water. So there's definitely some drawbacks to using coal. We also use oil. You're very familiar with that. The advantages of oil is the technology is already developed. It's already in place. We know how to get it out of the ground. We know how to turn it into gasoline. We know how to put it in cars. All that stuff is developed. The infrastructure is there. We don't have to do any developing there. It's already done. So that's super easy. It's something we've done for a long time. So disadvantages, again, not very energy efficient. Releases all of these pollutants into the air that affect our climate and our atmosphere and our health. And we may have roughly 40 years of oil left. This is a really tough number to determine because not a lot of oil companies or countries will release their exact amounts of oil that they have left. But our numbers are dwindling. We're having to do a lot of things to get to oil now. We're doing tar sand oils in Canada. We're doing a lot of fracking, which allows us to get to oil we couldn't get to before. Our oil rigs, offshore oil rigs, are getting deeper and deeper into the ocean to find newer places. We're hoping that the ice in the Arctic retreats a whole bunch so that we can drill oil in the Arctic off the ocean floor. So it's getting more difficult to find oil. When we first drilled oil rigs in Texas, you would get 100 barrels of oil for about 1 barrel of energy output to try to get that oil. And now if you use like the tar sand oils in Canada, for example, they get 3 barrels of oil produced for 2 barrels of energy output. So we're getting to the less and less efficient sources of oil because there aren't the easy ones anymore. Cool.